Okay, class, so we're going to learn a new concept today. This is a statistical concept. So we're going to go ahead and look at some data and figure out what that data means. Our main focus is going to be on mean absolute deviation, which basically means we're finding the mean of the mean so that we could figure out how far our data points are from the mean. And at the very end, I'll explain why we need to do that. Okay? So I have two sets of data here. I'm going to go ahead and plot this data. So I have a 2, a 4, and a 4. Over here I have 1, 1, 6, and 4. Okay, so in terms of the data, you could already see there are some similarities, there are some differences, there are some things that we could say about the spread of the data. As you can see over here, this data is a little bit more consistent. It's less variable because all of the data points aren't as spread out. But if you look over here, you have data over here at the 1 and data over here at 6. We have one at 4. It's really non-symmetrical and the data is really spread out. So we would say that this data set is less variable, all right? And this data set is going to be more variable just because of the way the data is spread out, okay? So let's go ahead and calculate the mean absolute deviation. In order to do that, we first need to figure out what the mean of each data set is. In order to figure out the mean, we take the average, meaning we add all the numbers up. So we have 2 plus 2 plus 4 plus 4. And we're going to divide all of that by the total amount of numbers there are. So as you can see, there's 1, 2, 3, 4 numbers. Okay? So my mean is going to be 2 plus 2, which is 4, plus 4 is 8, plus 4 is 12, 12 over 4. So my mean in this case is going to be 3. So I'm just going to go ahead and star this right here. This is my mean or my average, otherwise known as one of the measures of center when we look at data. Okay? All right, so let's go ahead and do that for the other side. We have 1 plus 6 plus 4, and we have 1, 2, 3, 4 data points. So that's all going to be divided by 4 in order to get the mean. Now, we have 1 plus 1, which is 2, 2 plus 6 is 8, and then 8 plus 4. Oh, okay, so this is interesting. We're going to get the same mean, okay? So we get the same mean for both sets of data. But notice how different these sets of data are, okay? The next thing I'm going to do is I'm going to take the mean and figure out what is the absolute value and the difference of that absolute value, okay? So here is how we do this. How much does it take to get from 2 to 3? It takes 1. It takes 1. How much does it take to get from 2 to 3 again? It takes 1. To get from 4 to 3, we're taking away 1, but the absolute value of that is still 1. And then lastly, to get from 4 to 3, we're taking away 1 again, but the absolute value of 1 is 1. So we're going to take all of those numbers and divide by the total amount that we have, 1, 2, 3, 4. So we have 4 over 4 is going to be equal to 1. So in this case, my mean absolute deviation is just going to be 1, okay? Now let's take that and do it over here. So the difference between 1 and 3 is 2. The difference between 1 and 3 is 2. The difference between 6 and 3 is minus 3, but remember we're only taking the absolute value, so we just need 3. And then the difference from 4 to 3 is going to be 1. Okay, so when I add all of those up, I have 2 plus 2, which is 4. 4 plus 3 is 7. 7 plus 1 is going to be equal to 8. So as you can see, our mean absolute deviation for this data set is going to be 2. This is my mean absolute deviation. Okay? So, as we can see, this has a smaller mean absolute deviation. This has a larger mean absolute deviation. If you look at the data, that makes sense because the mean absolute deviation is how far away our mean is from our actual data sets. So the lower the mean absolute deviation, less of a spread you'll have. It's least variable. It's less variable, I should say. Okay? But the more or the higher the mean absolute deviation is, it means the more variable your data set will be. So let's think about real life. Let's say that, this was a part-time job. In this part-time job at company A, you worked 2 hours, 2 hours, 4 hours, and 4 hours for a particular week. For job B, you worked 1 hour, 1 hour, 6 hours, and 4 hours. Okay? So my question would be, which job would you rather have in this situation? Just strictly on the hours. Which job would you rather have? Okay? So it turns out that we'll have the same amount of hours each and every week, but with this job, your hours are a little bit more predictable. You'll know you'll have in between 2 to 4 hours every single week. Over here, on the other hand, you can have 1 hour 1 week, you can have 6 hours 1 week. So the data is spread out really, really wide. So you actually don't know on a given day how many hours you're going to work. So if it was me, I need a more consistent schedule. So I would go ahead and go with company A because it has the least variability. I'll know more about the hours I need to actually do rather than less about that, okay? We'll go over more applications in class. Is there a particular case in which you would want more variability? Think about that question and we'll address it in class.